All right, it's time for our last video, okay? Now we're going to look at domain and range. So domain and range is something that you're going to have to be familiar with because you're going to see it for a long time in math. All right, domain is talking about where you have x values. So it's talking about the x values for your graph or for your function. And the range is talking about y values. All right, we have two ways that we kind of discuss domain and range. The ones we're going to focus on now, a big one's interval notation, but then we also can write it as an inequality. Okay, so interval notation looks kind of weird. It goes back to that open closed circle thing that we've talked about some, right? Remember, if you are saying all the x's that are greater than or equal to something, we have that closed circle. If it's just greater than, it's going to be an open circle. So here, if it is greater than, we're going to use, if it's or equal to, we're going to use brackets. All right, so this is what we call inclusive. It's including those points. It's or equal to. I'll write that too. Or equal to. Okay, if it's not inclusive, right, that means it's exclusive, so we're excluding it, right, then that's going to be parentheses. All right, and you'll see in a second, we can mix it. You can have some brackets, some parentheses. Right? And then another symbol you got to be familiar with is our infinity. So that means it goes on forever. And our infinity symbol looks like the sideways 8, right? I'm sure you've seen it. Just so you're aware, I draw mine as double zeros. Okay, same thing, just not as pretty. When I get going fast, these infinities start going diagonal and looks like 8, so I just don't even do them that way. I use double zeros, so just so you're aware. All right, the inequalities. Let me get to a different color. Our inequalities, you write just like an inequality. So we have either greater than, less than, right? These are the ones that are, these would be exclusive. We're not including those numbers. And then you have the or equal to's, and those are the ones that we do. So that's inclusive. All right? And then sometimes, instead of infinity, we want to say it goes forever. So it's all real numbers. So my symbol for all real numbers is what we call a double-stemmed R, right? And so this means all real numbers. Okay, and when we say that, because you have to have an inequality, like we'll say x is greater than something, we wouldn't say x is greater than all real numbers because that's a concept, not a number itself, not a value. So we use this like curvy E looking thing, and that is an element of. Is an element of. Okay, and all that sounds kind of silly, so we'll do a couple examples real quick before we get to our graphs. All right, so for example, we'll start with the inequalities because those are a little easier to think of. So if I was solving an inequality, and like we did the other day, I would get down to something like x is less than or equal to 2. All right, so that means I want all of the x's that are less than 2, and it's including 2. All right, so if I think about my number line, right, I would go to 2, I would use a closed circle, and then I would arrow to the left, right? And that arrow never stops going left. It goes left forever, right? So that means it's going to be going left to an infinity, specifically, right, a negative infinity. So we have a positive infinity that goes to the right, and a negative infinity that goes left, right, in terms of a number line. So then if I want all the x's that are less than or equal to 2, that means that I want everything going to negative infinity up until 2. So the way I would write that in interval notation is I would say negative infinity, comma, 2. All right, for interval notation, I put my starting value and my ending value. Okay, now the 2 is going to have a bracket because it's or equal to. All right, the infinities, no matter what, always, always, always get parentheses. Okay, just like with our all real numbers, I can't put a less than, greater than, or anything like that because all real numbers is a concept. So is infinity. So either infinity will always get a parentheses every single time. All right, another thing about infinities. Negative infinity will always go on the left side because there's nothing more negative than negative infinity. Right? And then positive infinity will always go on the right side because there's nothing more positive than positive infinity. That's the highest value you can have. So whenever you use interval notation, it's always your smaller value to the bigger value every single time. And you put your starting point, your ending point. Okay? So now we talk about x's and y's. Right? I'm going to give you a graph and you just have to tell me your domain and your range. So I'm going to start with inequality because that's a little bit easier just because you're used to it. So for this first one, if I start with the domain, okay, I'm just going to label it with a D. Okay, my x values, right, remember x values, I'm going with the x-axis here. So if I come all the way to the left side of this function, right, here's where my x's start. Then if I go all the way to the right side, as far as they go right, this is where they stop. Does not matter what happens in between. All I care about is the far left and the far right. So if I was going to write this as an inequality, I'm going to say my smallest value, which is a -3, all right, and you always use less thans, so you put x in the middle with less thans, and then my farthest right value is a 2, 3, 4, 5. All right, then I have a closed circle, so that's got to be or equal to, and then I have a open circle, which is just less than, so I don't have to worry about that. Anytime you do inequalities with domains, or with your domain and range, if it is a number to a number, you're always going to have this set up, and you just have to decide if it's or equal to or not. Okay, then if I wanted to do that in interval notation, I'm just going to put my starting value to my ending value. So my starting value is -3. My end value is a +5. Okay, -3 is or equal to. It's a closed circle, so I put a bracket. The 5 is not or equal to. I'm not including 5 in that, so it gets a parentheses. All right, and then my range. If I do range with intervals, right, my bottom y value, the very lowest that it goes, is that open circle down there. It's not always going to be one of the ends of your graph, right? Like this little valley here, if it had been lower, wherever that stops, that's my lower value. But this is the bottom of my graph. There's nothing lower than this point. The top is up here. There's nothing higher than that point. So my range is talking about this gap here, this interval. Okay, so I'm going to put the bottom, right? My bottom value is at a -2. Okay, oops, less than, but now I'm doing range, so I switch to y. Less than my top value, which is a 3. Remember, you always go smaller to bigger. So it's left to right, bottom to top, every single time. Okay, then I do have a closed circle up top again, so that top value gets the or equal to for my range. All right, interval notation, I put the starting value to the ending value. This one is open circle, so it's not included. This one's closed, so it is. So there's my interval notation. Okay, for number 2. All right, this is our quadratic, right? Man, we talked about quadratics and our parabola shapes. All right, if you have an arrow here, right, that means as far as you know, it doesn't stop. Okay, so it's going to keep going on and on and on and on up and to the left. It's never going to stop. I mean, it looks like it might take a while to get there, but it's going to eventually keep going left forever, right? So if I go left forever, right, that's getting smaller values, right, getting more and more negative. That's negative infinity, right? And then if I go to the right forever, that's positive infinity. Okay, so that means I never stop going left, I never stop going right. So I'm going to cover all possible x values with this graph. So if I want to write that, let me get a little separator here. Wrote a little bit big. So for my domain here, right, if I want to write that in inequality form, that's what I'm going to do this element of. And we're going to say all the x's that are an element of all real numbers. That's everything. That's how we write every x value. Okay, in interval notation, I'm going from negative infinity to positive infinity, and infinities always get parentheses no matter what. Remember, negative will always be on the left. Never, ever, ever will it be on the right. So it's always negative infinity to positive infinity. All right, then our range. Okay, for the range, I do have a minimum value. I have a bottom down here, right? But then it's going to go up forever. So if I go up, I'm getting positive, so that's going to be my positive infinity. All right, so now for an inequality, I start here and I go up forever. That means I want all the y values that are bigger than this bottom value. So that means I want all the y's, oops, wrong color, getting confused. I want all the y's that are greater than this -2. Okay, now this point right here, that's a part of my graph. It's not an open circle. I have a point right there. It's not a hole. So I'm going to put or equal to. All right, then for interval notation, if I start at the bottom and go up forever, my starting point is -2, and then I go up to infinity. Infinities always get a parentheses no matter what, and the -2 is not an open circle, so I'm going to include it. That's part of my range. Okay, for this one, right, for my x's and my my domain, it's going to go left forever. Remember that arrow means it's going to keep going that way forever. So this one is going to go to negative infinity, and then it's going to go to the right forever too. So it's going to go to positive infinity. All right, if I talk about my range, my up and down, it's going to go down forever. It's not like this parabola where it comes down and then starts going back up. Right? It's going to go down forever. Well, if I'm going down, that's getting to more and more negative. Down is negative infinity. And it's also going to go up forever, which is our positive infinity. Okay, so I'm going to switch it up this time. I'm going to do interval notation first. So if I go left and right forever, that's negative infinity to positive infinity. Anytime it goes left and right forever, this is going to be your domain. If it goes up and down forever, that's also our range. Okay, negative infinity to positive infinity is the same as all real numbers. So if my domain is all real numbers, I'm going to say x is an element of my double stem r. If range is all real numbers, I'm going to do the same thing, but we use y because I'm talking about the y values anytime I talk about range. Okay, then for the last one, our very last example. Okay, this one is actually our exponential curve, and we talked about that a couple days back, and there was a part of the exponential curve that it's part of the graph, but you don't technically see it, and that's our asymptote. So remember we talked about this curve, how it comes down, and then it flattens out, right? And you hear like us talking about right now with COVID. Okay, all this stuff with COVID is talking about flattening the curve, right? That has to do with exponential, because eventually exponentials flatten out. All right, so here, this is going to flatten out, and it's going to get super, super, super close to that x-axis, but it's never actually going to touch the x-axis. So keep that in mind. We'll start talking about our domain and range. All right, so domain and range. All right, domain's an easy one because if I look here, it's never going to stop going to the left. So that means that as I go left, I'm going on forever and ever and ever, so that's negative infinity. Right? And then it's also never going to stop going right. It might take a while to get there, but it's going to keep going right, just like our parabola over here is going right. So I'm going to be going right forever, which is positive infinity. So our domain is all real numbers, negative infinity to positive infinity. And then as an inequality, we say x is an element of all real numbers. Now the range is a little different. Okay, the easy part of the range is that this is going to go up forever. That's guaranteed. It's going to keep going, going, going. But it's not going to go down forever, okay? Because it's going to keep getting down farther and farther and farther, but it's not going to pass that asymptote. Okay, I don't know if I cut off, but it's not going to pass that asymptote there, all right? So it's going to keep coming down, 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 and believe it or not, between 0 and 1, there's an infinite number of points. There's so many points right there between 0 and 1. Because if you think about it, if I want to get close to 0, I can go 1 to a half, to a third, to a quarter, right? Or that's, 0.25, right? Or I can go to 0.01, 0.0000001, 0.000000001, and it just goes on and on and on. All right, so I can get infinitely close to 0 without ever actually getting to 0. All right, so then that means it's going to keep going down, but it's not going to get to 0, but 0 is going to be our boundary. That's like our starting point, okay? So then that means my starting value in interval notation is 0, and then I'm going to go up forever. But because it's an asymptote, because I never actually hit 0, it's not including it. It's excluded, so it's going to get a parentheses. Asymptotes, write it back up here. Asymptotes always get parentheses, just like infinities, because you never actually touch that asymptote. We never actually hit that value. But it is still a boundary, right? Because I can't pick 0.01, because then there's also going to be 0.001. It can get smaller than that. So we use our asymptote as a boundary. All right, then when I write this one as an inequality, I say that I want all the y's above that asymptote. So I'm going to say I want all the y's bigger than 0. But it's just greater than, because I'm not including the asymptote. We never actually touch the asymptote.